Sean, doctor, has introduced me. I'm not going to introduce myself. So this slide is my introductory slide. He already handled that. But I've done some stuff over the course of my career. ADSecurity.org, I came up with a way to make golden tickets more powerful, but also published how to detect them. I also published how to detect curb roasting. I've done a lot of work on the offensive research side, but also on the defensive research side. And so the agenda for this talk really is looking at the history of a decade plus of what we've been dealing with from identity protection. This is the Hybrid Identity Protection Conference, so it makes a lot of sense to cover this topic here. I'm going to go through the Active Directory attack timeline, basically how we've gotten to where we are with things being difficult to secure Active Directory. And then I'm going to focus on Entra ID and talk through the attack timeline, at least some of the things that we've been seeing over the past decade or so. And then I'm going to wrap it up with some things that we can do to help protect ourselves. But in the beginning, there was Active Directory. And I'm going to talk about the Active Directory attack timelines, as I mentioned. And during a timeline that I call the baby steps, so 2000 and 2009, we had the first pass-to-hash idea and concept, which was in the NT bug track listserv. We had SMB Relay, SMB Relay 2. We had NBN spoof tool, which is basically the originator for like Inve and Responder. And then we had the pass-to-hash toolkit, which was done by Hernan Ochoa. Sorry, Hernan, probably mispronounced your name. And so then we go into the Wonder Years, and with the Wonder Years, we're looking at a variety of different tools, as I mentioned. So we have Windows Credential Editor by Hernan Ochoa, we have Mimikatz, we have Responder, we have PowerView. And we have privilege escalation, which is basically our group policy preferences. We have pass the ticket, overpass the hash, Kerberos, and golden tickets and silver tickets for persistence. So this is a conceptual overview of how that looks. And basically we have PowerView and GPP password and pass the hash, pass the ticket, and Kerberos and how those move over into Responder. And then with Responder to something like invoke Mimikatz, or maybe just GPP password has a credential for domain admins, or a silver ticket or golden ticket gets used in order to get to DA. And then we have what we call the golden years, or what I call the golden years, from 2015 to 2019. And this is really where things go crazy. As you can see, there's a lot of different tools, a lot of different things that have come out during this time frame. From the tools perspective, we have DS internals, we have, having trouble reading, PowerSploit, Impacket, PowerShell Empire, DC Sync is added to Mimikatz, CrackMap Exec, we get Bloodhound, and we also get Rubius during this timeline. So there's a number of things that we get which are very impactful and really set the stage for the difficulty that we have in protecting Active Directory. Privilege escalation, the DNS admin sort of feature bug, where you could go from DNS admin to domain admin just by getting a DNS admin account because of the way that DNS works. And then the AD permissions, lots of AD permission issues that we've had over the years that have just layered upon layered over time. And the so-called printer bug, which is if you're able to get on the network and actually influence the domain controller to print or send a print notification to another server that you can control, you can actually compromise that domain controller. And then resource-based constraint delegation, which really came out about because of Elad Shamir's Wagging the Dog document, which is impressive. Great white paper. It's a little tough to read, but so is Kerberos stuff, so that's how it goes. And then persistence, AD permissions, lots of chances and opportunities around that, and then DC shadow attack. And then we have the conceptual overview of this. Again, either Impacket or PowerSploit or DS internals or Bloodhound or Kekio. These tools actually influenced other tools. So from Impacket and PowerSploit to CrackMap Exec, DS internals to NTLM Relay X, Bloodhound in Empire, Kekio to Rubius. And there's a number of different conceptual flows with this as well, but some of them go from DNS admin to the domain admin, the printer bug, spool sample, over into domain admin, AD permissions to DC shadow, resource-based constraint delegation to AD permissions to then ultimately to DA. And then what I call the third age, 2020 to 2023, we have Avalanche, we have remote potato, petit potem, and then the certified pre-owned ADCS attacks, Black Hat talk by the folks at SpecterOps, which really cast a bright spotlight on the issues with Active Directory certificate services. And so they also released a certified tool which helps people identify which of these issues are actually there. The Kerberos relay attack by James Forshaw showed that, hey, we can also relay Kerberos. And the Certipy tool, which was a Python port of Certipy. And then Kerb Relay Up tool was released, which really showed how easily it can be, a lot of AD environments can be compromised. And CrackMap exec continues as netexec. So again, with the overview of the tools here, we have the Potato Podem, Certipy, Kerb Relay Up, and netexec as kind of sort of the key ones here. The privilege escalation around certified pre-owned Kerberos Relay, and then into persistence. So this third age conceptual overview really goes from these tools that I mentioned over into a few different buckets, either NTLM Relay, Kerberos Relay, or certified pre-owned using ADCS. And what's interesting about this is actually certified pre-owned can be used for NTLM relays and Kerberos relays and have been. So we're at the point now where ADCS is one of those key and core functions or features that we really have to look at securing in addition to Active Directory. And so this means we really need to structure solid Active Directory defenses around all of these issues, because obviously it's been a problem. We can break recon though by removing authenticated users from having access to everything, which is the default in Active Directory. But if we remove authenticated users from having rights on the groups, we need to have an auditing group to identify that. So working at Trimark, I've seen customers that have actually locked down the admin SD holder so that way authenticated users couldn't see into the highly privileged groups like domain admins, but did not actually set up an auditing group so that way someone outside of domain admins could check to make sure that someone who's not supposed to be in there isn't in there. And inevitably, we found some issues with that configuration. So it's important to have the view into it from an auditing perspective if you're going to lock things down. Same thing with GPOs. A lot of organizations will pull authenticated users from being able to see that group policy object because it only applies to, say, all the workstations in the domain. So what's important about that is, again, making sure that an audit group can still see into those and understand what group policy settings are getting applied. And part of this auditing is not just these custom groups, but also as we change the different read access. If we set up a secured OU at the top level, which is recommended, same thing, we need an audit group that can see into that and see the admin objects. AD privilege groups, like I mentioned, admin SD holder, local administrators, the group membership of those, group policy object view access. So these are kind of the top 4 things that we can do to help break recon, but we need to make sure that auditors can still see into these groups and into these configurations. And there's a number of things that are important from effective Windows system defense. I'm not going to go through all of these. Feel free to take pictures. We'll have the slides up on the Trimark Content Hub, and of course, it'll be published by the conference, which has them. But disabling LMNR will prevent and help lock down things like Responder, Inve, disabling NetBIOS, disabling WPAD, disabling LM and NTLM1, disabling SMBV1. These are all protocols that have been around since the early days of Active Directory, and Active Directory is 24 years old now. So it's really important to look at these things and how to lock things down. Continue in working through things like deploying laps, things like controlling Office macros, which Microsoft has started doing some of these things step by step, but they're really just kind of baby steps towards the ultimate solution. And then from the Active Directory administrative security, the most important thing you can do is protect the credentials of your AD admins. If you can protect the credentials of your AD admins and not let an attacker or red teamer or a pen tester get access to that credential, then you're going to be a lot more secure and you're going to be a lot better protected. Sensitive and cannot be delegated protects against the majority of the delegation type attacks. Ultimately, moving to protected users is the best way to get there. But the key thing is, again, protecting the credential. AD admins only log on to AD admin type stuff. We've got to keep a clean source principle, which means that if you're using a keyboard to type in your Active Directory admin password, that's on a system that's part of the tier 0 grouping of systems. So that way you can isolate that credential and protect them. And from a service account perspective, that matters. The cyber liability insurance companies end up paying millions of dollars, if not more, tens of millions, hundreds of millions of dollars, because service accounts get compromised. It's the number one way that an environment gets compromised. So if anyone here has service accounts in their organization that have passwords that are 3 years, 5 years, 10 years, God forbid, 20 years old, those have to change. And what is the biggest thing we hear? Well, we can't change it because we don't know what that will impact. But my question is this: how can you support an application if you don't know what will happen if you change the password for the service account? That cannot be a supportable application. So change that. Again, I'm not going to go through all these slides for the domain controllers, but they need to be physically secured. If that physical security includes something like AWS or AWS or GCP, or if it includes Azure or VMware, probably not as much now as what it was, but whatever system that's hosting the domain controllers, that's part of that physical security. That extends into your cloud data center. It extends into VMware, making sure that those platforms are secure as well. And then NTLM Relay is being used all the time now. So it's really important to configure auditing so to at least understand what systems in the environment actually require SMB v1 or NTLM in order to better protect them. But enforce SMB signing and configure LDAP channel binding and LDAP signing. That's a tough thing to do. But it's better to start that journey now than get compromised and then have to do it in a rush. So I'm going to talk a little bit about the Azure AD and Entra ID attack timelines, moving on from Active Directory, kind of in the beginning, into now where we are. I'm going to call this baby steps because there's a lot of things that we're in now that we weren't into, that we didn't have before. So in 2016, Mail Sniper was released by Bo Billock. And 2017, we got this Exploiting Azure AD Seamless Single Sign-On article by Michael Grafner. And we also had Evil Jinx that got released. I did a Hacking the Cloud DEF CON talk with Gerald Steer, which during that I talked about what later became known as the Golden SAML attack, and also security concerns with Azure AD Connect. Today, when I talk to pen testers and red teamers, I say, what are the most successful ways that you compromise an Active Directory environment? And it's always ADCS or Azure AD Connect. Those are the two ways that they say it. So we have to make sure that we're being very careful with these systems, especially these cloud integration components as well. So the Golden SAML tool was released late 2017. We have Evil Jinx 2 in 2018. Microburst AD internals were released by Dr. Azure AD. We have the Azure AD Connect for red teams article by Adam Chester, which really shows how you can attack that platform, that system, that hybrid identity connection into the environment. Then we have I'm in Your Cloud, Pwning Your Azure Environment from Dirk-Jan Malema. He later released a series of tools called ROAD tools. We have MSOL Spray, MFA Sweep, a lot of things. And ultimately, this means that attackers have better capability than they did. So if I go back and show you here, kind of 2017, 2018, 2019 is really sets the stage for 2020 and later. But these are the tools that we have to protect against today. These are the tools that the attackers have. It's never been as, I'd say that Azure AD, Entra ID, whatever you want to call it, or whatever Microsoft's calling it today, has never been at most risk as it has in the past because of these capabilities, because of privilege escalation. If you haven't heard of Evil Jinx, that is the attacker in the middle product that enables attackers to impersonate users by having that attacker in the middle type platform. And then Persistence, Golden SAML, AD internals, Magic Web, there's a bunch of them. And why are we in this place? Why are we in this situation? Well, this is Microsoft Incident Response. They put out a Microsoft Security blog article that's linked at the bottom. And they have these components. And then they talk about which of these components gets attacked. Okay, as you're looking at it, I want you to mentally put a red circle or box around each of these that you think could be attacked. And then Microsoft actually talked about this. So here are all the things that can be attacked. This is why it's so tough to protect hybrid identities today. And so Microsoft has released a number of information about how to better protect the environment, how to better protect Entra ID. So I'm going to talk about level 0, ultimately tier 0 in Entra ID. And this is complicated because there's over 100 roles in Entra ID. And out of these roles, Microsoft says 26 of them, as of a number of months ago, 26 of them are privileged. The challenge that I see with this is when we start tagging these things as privileged, we have a couple here that are not the same, kind of like Sesame Street. 2 of these things are not the same. We have global administrator and we have global reader. These 2 are not the same. So the challenge that I have with tagging things as privileged means that people are going to look at this and go, okay, well, global reader is privileged, global administrator is privileged. So I went ahead and bolded the ones that are actually very privileged, but I'm going to show you some better information on how we can represent that. So at Trimark, what we did was we went through and categorized all of the roles that we see that are level 0, so effectively tier 0. So we have global administrator, it's obvious. Hybrid identity administrator has the ability to manage federation settings. Partner tier 2 support, thanks to Andy Robbins, who dug this up. It's one of those ones that shouldn't be used, but he actually says not quite as powerful as global admin, but the role does allow a principal with the role to promote themselves or any other principal to global admin. So guess what? It's global admin. Privileged authentication administrator, Microsoft says do not use. We see a lot of customers actually using this. And privileged role administrator. So these last 2 have the ability to get access to an account that is a global administrator. And then level 1, these are the ones that are not as highly privileged, highly powered, but in some instances could become a level 0 role. I'm going to talk specifically about application administrator, cloud application administrator. These are the tools that have the ability to actually add a credential to an application. So if you have applications that have highly privileged role or highly privileged rights, these can actually go ahead and add a credential to that application and then get full rights to that environment. This is the second page of this. There is a partner tier 1 support in addition to partner tier 2. These are concerning. And so Microsoft has a chart that says which role has the ability to change passwords for the other roles. But honestly, I like Andy's chart a lot better. So this is the one that I use when I try to figure out what a role has the ability to change the password for another one. And this is through, obviously he's talking about service principal abuse. Can a user with role in column A reset a password for a user with a role in row 2? Pretty simple. So at another conference in 2022, I talked about these highly sensitive application permissions. So it's been a couple years that I've been talking about these. So I'm going to break this into what we call level 0 applications and the permissions of them. Directory rewrite all, Microsoft says this is effectively global admin, and I trust them, so we have to be protective of that. This second one, app role assignment read write all. This one I love. This is basically where the application can define its own permissions or the permissions of pretty much anything else. So this is effectively God level access for an application. So if we have an application with this, and we have a standard user account, just a regular old user account hanging out in application administrator, that user account has the ability to add an application to, or add a credential to the application that has this right, or any of these rights, it's game over. That Entra ID tenant can be compromised. We have role management, read-write directory, the ability to manage directory role membership so you can make it a global admin. And this last one is interesting because it has the ability to control any application. And most of the time I see that there's applications in the environment that are actually highly privileged that have one of these other 3 application permissions. So conditional access policies. I asked Copilot to make me a picture of conditional access policies because I thought it would be interesting to see. I did this little number cloud on the bottom. These are some of the numbers of the number of conditional access policies that we see in environments during assessments. And so I said, okay, Copilot, give me an image that represents conditional access policies and everything that it connects to. And so much like AI today, it can't spell. But it seemed to think that this had a group of people kind of talking to each other and trying to come to some sort of understanding, which I think represents conditional access policy pretty well. So conditional access policy, quick overview. You have the signal, you have the decision, and then you have the enforcement. So it's kind of the what-if policy around Entra ID or Azure Active Directory. They apply after the first factor authentication. So if there's a second factor like MFA, this happens before that. It does require P1 licensing, but there's rules based on who's connecting, where are they connecting from, what app and/or device is connecting, and when does this apply. So kind of the things around what a reporter needs to know, the who, what, when, where, why of what's going on. And Microsoft has this really great image here that I really like because it shows that zero trust is as easy as just using these Microsoft technologies, and then it all works, right? So conditional access policy, we have this nice little view here. Microsoft has done a pretty good job of updating the view into this using the web portal app. We have our all policies, Microsoft managed policies, which we'll talk about a little bit, and our policy names and the state. The challenge is that these kind of just all sort of apply. So it can make it a little difficult to figure out what is actually applying and happening with our users. There are some common conditional access policies that we see. Require MFA when outside the corporate network. Require MFA for users with certain admin roles. Block legacy authentication, which is a good one to have. Block or grant access from specific locations. So these kind of capture all the major types of conditional access policies that we see. So number one, we call this conditional access policy gap. So users require MFA outside of the corp network. The crazy thing here is that attackers are on the network. We know that they're on the network, but we're not going to force our users to MFA when they're on the network because we don't want to burden the users. We got to stop doing that because attackers love single sign-on. It's just the way it is. Admins don't require MFA. This is something that we've seen too frequently in the past. It's getting better. But MFA is required for certain users to access specific applications, but there's no conditional access policy requiring MFA of admin users who are in global admin or in some of those highly privileged roles that we talked about. And again, attackers love single sign-on. Exclusions. So creating a great conditional access policy that has a lot of great settings that locks down the environment, but then excluding certain users, certain accounts, certain groups from those actual roles, or from that conditional access policy that has that powerful protections. And attackers love being excluded from these. So there's a few different types, baseline policies which have gone to the wayside. We have conditional access templates, which are really nice. Microsoft sets these and you can go ahead and add them to your environment. And then the Microsoft managed policies. So in the past we had our baseline policies, but now we have security defaults. Security defaults tend to take effect if you're not using conditional access policy, but we've seen customers kind of struggle with conditional access policies. So Microsoft has their Microsoft managed policies. And what's nice about these are a set of policies that Microsoft's ultimately going to manage and control. So this means you can't change them by much, but you can duplicate them. So that can be helpful, especially if you're struggling to figure out how best to protect your environment with a conditional access policy. This is a good way to start. And it currently focuses on 3 areas: MFA for admins, accessing the admin portals; MFA for per user MFA, configured on users; and MFA and reauthentication for risky sign-ons. These are the things that really will help protect your Azure AD Entra ID tenant. And then let's talk about attacking Entra ID. So first of all, there's phishing. We know about that. I'm a Nick Cage fan, so you'll see Nick Cage in a lot of these slides here. Basically impersonating someone else and getting access to their computer. Stealing tokens from the web browser. This is crazy simple to use. I use this really complicated attack tool called Chrome on my computer in order to do this. It's very easy to do because ultimately the token is stored in the browser, is there. And so if the attacker can attack the browser, then they can extract one of the tokens or all the tokens that are in that browser. And all they have to do is transfer that over to something else and use it. And it's pretty easy to do. Again, I only use Google Chrome, the web browser, to do this. Copy it out, and then I checked it at jwt.ms, and I can see what what the user is within this token. So I can very simply and easily look for admin tokens in a web browser. And with that, I have the access token. That means I have access, the same level of access that that admin does, just because I had access to the web browser, because I had access to that computer. And thank you to Nestori, Dr. Azure AD, for helping me put that together and sort through which token is which, because there's a lot. But if I'm a little more complicated and a little more sophisticated, let's say that I decide that I don't want to just attack the web browser, maybe I'll just add an extension. You can do that with a group policy. So if I can control group policy, then I can add an extension to the web browser, and I can have that extension just pull those tokens out of the web browser for me. Or I can use evil jigs. Again, I was talking about the attacker in the middle. This is the perfect situation that I was talking about, where either somehow we influence where the admin is going. If we influence them to go to this, this portal, azure.com, which isn't real, or at least isn't the real one, then we can get the attacker to go to, we can get the admin to go to that site. Then we just have attacker in the middle and basically prompt the user with the same prompt that we're getting from the real portal.azure.com. And EvilJix just sits there, and now we have the token. And again, the whole situation is we're just approving the sign-on request on the one side, we'll approve it on the other. It's the exact same thing that's getting passed over, so that way the user thinks that MFA is working the way it's supposed to. We need to use things that are MFA, or we need to use better tools around this, or better ways to protect our tokens, such as FIDO2. So here's an example of an overprivileged user. This user account is a member of groups and roles that are highly privileged, but the attacker is going to compromise this user account because it's a member of conditional access administrator. It's also a member of application administrator that can add credentials to an application. It's a member of user administrator. We can change passwords for a number of different accounts within the environments. And then partner tier 2 support. So that partner tier 2 support is one of those level 0 roles that I mentioned. So this means that once we compromise this user account, we compromise Azure AD. An application administrator, or application escalation. What we can do is look to see which applications have which permissions. So here we have applications with a number of permissions that are highly privileged. Directory read-write all, application read-write all, app role assignment read-write all, role management read-write directory. That's pretty much all of them there. And that's common. It's common to find these permissions already configured on applications in the environment. And we can find the application owner. Fun fact, the application owner has the ability to add credentials to the application. And most of the time, the application owner is a standard user, a regular user account. So we have this account that's a regular user account. An attacker compromises it and then goes, oh, wait a second, this account is an owner for this application. So I'm going to add a credential to that application because that application has role management read-write directory permissions, which means that once we compromise that user, we can then impersonate that application and we can add a member to global administrator, which enables us to compromise Azure AD. We can also do the same thing through application permissions when we have an account that is a member of application administrator. So we have this account, it's a standard user account. It gets compromised. It's a member of application administrator, which has the same ability, the ability to add a credential to an application. So it does that. And then it impersonates that application as a member to global administrator and is compromised. So there's also these things called role assignable groups that Microsoft put together. Role assignable groups are really interesting because Microsoft said, okay, well, in Active Directory we had groups that could be a member of other groups, could be a member of other groups, so that got very complicated. But we're hearing customers that want to be able to put groups into roles. So how do we do that? Well, we won't do the same mistake we did before, which is if we just made it so that any group could be a member of any role, then the groups administrator would have the ability to modify that. So what we'll do is we'll create something called role assignable groups, create them as a special type of group in Azure AD, and then we'll make it so that only the global administrator and the role administrator have the ability or the privileged role administrator have the ability to change the membership and control that role. Except when you add an owner to it. When you add an owner to it, that owner has the ability to add membership or update membership of that role assignable group. So again, we have our attackers compromise this account. That account is an owner of a role assignable group, which is a member of global administrator. So once we're owner of this, the attacker can take advantage of this control, add a member to global administrator, and then Azure AD is owned and compromised. There's another interesting thing that came out of the whole SolarWinds issue on the cloud side. It was determined that an attacker had compromised a cloud service provider in order to compromise that tenant. And so this sort of tenant hopping was a situation where we have a partner delegated, who is a delegated administration to one tenant, and that tenant is managed and has control. But it could be also another interesting thing where an account in tenant A also has control of tenant B. So we end up with this weird sort of Entra ID trust type thing, which is something that needs to be looked at as well. So try to keep all of your administrators in your same tenant unless you're using some sort of concept of a red tenant. Well, what about admins that are synchronized from on-prem AD? We have our admins that are in our on-prem Active Directory, and those accounts are synchronized up and are added to Sable Global Admin. Well, Andy Robbins says don't do that. So I think it's a good idea not to do that because he shows from domain user to global admin and how that path can be followed. So yeah, just don't do that, okay? I know that's hard. I get a lot of pushback from it. We get a lot of pushback from that because there's these very complex user management systems that are in place. And that's the reason why companies want to have a setup that looks like this. The problem is you don't want to be an example screen for SpecterOps at their next talk. So don't do that. So Midnight Blizzard, I'm going to talk a little bit about what happened with Midnight Blizzard. And I asked AI to generate an image for me, and I was like, wow, that's pretty cool. I think CrowdStrike's going to get mad at me because they have their own action figures of what these look like. And then I asked it for another one, and I think it thought that I was talking about Blizzard, the game company, because that kind of looks like that. But Microsoft said that we had an attack by Midnight Blizzard. Midnight Blizzard is one of the Russian attack groups, one of the better ones. And they say that there was a number of things that happened, and they investigated what happened and how that worked. So let's talk through how that happened based on public information. So they had a test tenant which had a legacy test OAuth app which had some rights to the production tenant. What they did was the attackers password sprayed accounts that didn't have MFA. So they were able to compromise an account. That account had access and control of a non-production system, which had control somehow to this legacy test OAuth app, which then enabled the attacker to create additional malicious OAuth apps in the production tenant. And with that, they were able to, with their access that they had, they were able to create a brand new account in the production tenant and somehow use that to then accept access permissions for those new malicious apps that they created. And from there, they had full access as the app, permissions to Exchange Online. So what this means is the attackers were able to impersonate Exchange Online, the system itself, to Exchange Online. So if you think that's a bad thing, you're absolutely right, because the next thing they did was they downloaded all these mailboxes, all the data from all these mailboxes. This next slide is just a summary of what we know based on the published information that went to news articles around the world. I'm not going to go over this because I just talked through it. But the important thing to understand around all of this is that Microsoft noted that this happened. They tracked what had been going, what had been done. And then they say, it is apparent that Midnight Blizzard is attempting to use secrets of different types it has found. Some of these secrets were shared between customers and Microsoft in email. And as we discover them in our exfiltrated email, we have been and are reaching out to these customers to assist them in taking mitigation responses. So Microsoft got caught with a situation where they knew that that shouldn't have been there because test non-production system had access to production system. We see the same thing. So this is not just a Microsoft situation. Using something like canary tokens can help to identify this sort of situation if an attacker is compromised and pulled access or pulled information with access. So I also asked Copilot, create an image for me of securing Entra ID administration. And this is what it came up with. And I thought that was pretty good. I mean, we got this scanner thing that's scanning the person who's actually doing the scanning, and then it's somehow scanning from there to the person who's into this little like TSA portal thing. Pretty cool though. I love Copilot. It's lots of fun to play with. So Microsoft said this is the best way that you can secure Azure AD Entra ID, and I'm not going to go through all of it, but I'm going to talk about some of the key points, just like with the tier model. The tier model in Active Directory, the most important thing you can do is focus on tier 0 and protect that level of administration. Same thing with Azure AD, protect your global admins. Microsoft talks about protecting these and how these Azure AD Microsoft 365 admin accounts should be created in Entra ID, required to use MFA, secured by conditional access, and accessed only by Azure Managed Workstations. So when I say Azure Managed Workstations, that's what Microsoft said. So what you should be hearing is some sort of privileged access workstation that's protected at the very least. Another good way to do this, to protect your environment, is to actually start down the path of ensuring that your admins, when they're logging onto their cloud admin system, or sorry, they're logging into their cloud system that they're an admin on, that they at least use a VDI, or they use some other web browser that's not on their standard workstation, because that's going to be attacked and it's going to be compromised. So Microsoft ultimately says manage from a cloud controlled device. No on-prem account has Azure AD, Microsoft Office 365 privileges. Remember we talked about those on-prem rights, on-prem accounts being added to those systems or the rights within the cloud. And then use Azure AD Cloud Authentication, and definitely FIDO. And one of the things that really helps is just about every environment now that has Active Directory also has the Microsoft Cloud. They have Azure AD Entra ID. And these accounts are synchronized. So these accounts are synchronized. So if you have a bad password policy in Active Directory, where you have 7 characters, 8 characters, 9 characters, that could be compromised, that could be password sprayed. And if you're using Azure AD Connect to synchronize those password hashes up, then the attacker can go ahead and password spray at Entra ID. So using something like Entra Password Protection or some other password protection to prevent the users from using bad passwords is highly recommended. So phishing defensive layers require users MFA, preferably FIDO2, because that will protect against that attacker in the middle scenario. Use conditional access for ensuring that MFA is being used even on-prem on your corporate networks. And risk-based policy, so prompt when the risk is protected or risk is detected, so that way we can ensure that if there is something that's going on that's hinky, so to speak, I know I'm not supposed to use unknown words, but if it's hinky, we want to make sure that the system itself knows about it and tries to get it fixed. And again, we need to protect those cloud administrators. Protect that credential. Same sort of concept that we've looked at Active Directory, we've been doing to an extent in Active Directory, we need to also do with the cloud. And there's common persistence methods that attackers are using. Illicit consent grants, so basically the OAuth consent. It's not just Microsoft, it's also Google Apps. It's out there. This is a industry standard, so it's not just Active Directory, not just Azure AD, not just Microsoft that is getting attacked using some of these methods. Review the Exchange forms and rules for potentially malicious settings, and review Exchange Online mailbox permissions for unusual and unintended configuration. So ultimately, in conclusion, attackers are targeting the cloud. They're identifying these common security issues and resolving them. It does improve your system security. And fixing these issues improves your breach resilience. So ultimately, that's been my time. Thank you very much for yours.